Hello everyone, my name is Julio Constantino. I'm going to be presenting the PowerPoint on Trenchless techniques for the class CIBE 6324 Construction Methods and Equipment. This PowerPoint was worked on by Bahara Bethe, Yelitza Soto, Mary Balanca, and me, Julio Constantino. The outline for this presentation consists of the following. We are going to talk about what are Trenchless techniques, history of this technology, cities adapting to Trenchless techniques, Trenchless construction methods, Trenchless renewal methods, the future of this technology, and conclusion, along with references. Now, what are Trenchless techniques? Trenchless techniques, or Trenchless technology, is an underground construction method that requires a few trenches or no continuous trenches for installing, repairing, or renewing underground utility lines such as underground pipes, ducts, or electrical cables. Trenchless technique construction reduces traffic congestion because the methods can be carried out under a busy highway. It also results in less air and noise pollution, and this method of construction is also less hazardous to workers because it can be controlled from the surface. This technology was first invented by Eric Wood, with the first success of Trenchless technologies in 1971, consisting of cured in place piping. Several methods followed afterwards, which included pipe bursting, cast iron pipes, and microtunneling. There was a lot of skepticism at first of using Trenchless technologies. However, after people saw the benefits of it, this type of technology gained popularity very quickly and ended with high quality results afterwards. Trenchless technologies offer a viable solution to help decrease the risk of underground installation damage and provide less disruption to cities and more convenience to the public, with four main advantages, which consist of number one, decreasing disturbance, whereby we reduce the need for invasive excavations and have a lesser impact on the surrounding environment. Number two, safety, whereby excavation can be one of the riskiest aspects of construction. Safety is paramount, and here workers can rely on the safety assurances provided by the Trenchless technology. Improved accuracy, whereby the technology can carry out complex procedures to a very high standard of accuracy with minimal disruption to the surrounding area. And finally, it's financially friendly, whereby the cost of this technology and using it in our projects, the cost can be quickly regained. Now, there are two types of Trenchless methods. First type being Trenchless construction methods, in which we are constructing a system to replace an existing facility. And next will be Trenchless renewal methods, whereby we are upgrading, rehabilitating, repairing, or renovating the performance of an existing system. So these are the two types of Trenchless methods. The different types of Trenchless construction methods include the following: auger boring, impact molding, pipe ramming, microtunneling, and horizontal directional drilling. Auger boring is used for the installation of steel pipes and casings, especially under railways and road embankments. Some of the advantages of this Trenchless technology is that it is very economical and it can reduce the damage to pavements and disruption to traffic. Hence, this reduces social costs associated with pipeline installations. The disadvantages, however, is that with auger boring, the samples are highly disturbed and mixed. Not only that, but work may be held up, and auger boring is not really suitable if there are large cobbles, boulders, or other obstructions present at any depth within the soil. Next, let me show you a video on the process of auger boring, and this video will show in detail how this Trenchless technology works and what it can be used for. Impact molding consists of a pneumatically driven machine, known as a mold, which forces its way through the soil along the desired path of the pipe. The mold is a steel cylinder about 60 centimeters long and 6 centimeters in diameter. It works as a pneumatic cylinder with post-compressed air, causing the head of the mold to repeatedly hammer against the soil in front of the mold. Now, some of the limitations of this technology is that this method is strictly restricted to a relatively small diameter lines in compressible soil conditions. So it has to meet these qualifications. Pipe ramming is used for the installation of steel pipes and casings over distances usually up to 30 meters long and up to 1.5 meters in diameter. This technology is used for shallow installations on the railway lines and roads, with some of the advantages being that it can be applied for horizontal as well as vertical installations. And the method here is also pneumatic. Now, the disadvantages of this trenchless technology is that there is no control over the line and rate of installation, and there's a chance that the pipe will be deflecting if met with hard obstructions. Here's a small video detailing again some of the details with pipe ramming and its usage in the industry. The next technology is microtunneling, and this type of technology is capable of excavating to a full tunnel diameter. Some of the uses for this technology is will be tunneling through mountains, undersea tunneling, construction of subways. Some of the advantages of this technology is that it handles a wide variety of ground conditions. There is no use for dewatering, minimal surface disruption, and the thing about this technology is that it can be very accurate. Sloping of 0.2% is easily achieved here. Now, some of the disadvantages of this technology, however, is that it requires a large area for jacking shaft and support equipment. With this technology, relatively, you're going to be having a high cost, and if there is an obstruction in when doing the tunneling, the obstruction is going to be problematic for this technology. Next is a video showing the details of pipe jacking and microtunneling.
The first stage of construction is to prepare the drive and reception shafts, usually at manhole positions. The drive and reception shafts must be long enough to accommodate the tunneling equipment. A concrete base slab is poured to support the tunneling equipment, and a thrust wall is provided where necessary, giving a solid surface from which the pipes can be jacked. Then an entrance sealing arrangement is installed, through which the microtunnel machine and pipes can pass as they enter the ground. And finally, the hydraulic jacking rig is installed. Then the microtunnel machine, the real workhorse of the microtunneling process, is lowered into the drive shaft and onto the jacking rig. The drive begins with the microtunnel machine being thrust forward by powerful hydraulic jacks, first passing through the entrance sealing ring, then tunneling through the ground on its journey to the reception shaft. Once the machine has reached a predetermined position, excavation is halted, cables and hoses are disconnected, and the first jacking pipe is lowered onto the jacking rig. The pipe is pushed up to the back of the microtunnel machine, where the two are linked together, often by an adapter ring, and the cables and hoses are reconnected. Then, pipe and machine are jacked forward as the excavation at the face of the machine continues. Finally, the microtunnel machine exits the ground into the reception shaft, completing the drive. The machine and equipment are lifted and removed from the site, and manholes are built, ready for project completion. Microtunneling is the perfect choice for deep sewer and pipeline installations.
The last trenchless construction method we have here is horizontal directional drilling. Now, this technology is used for the installation of pressure pipes under major obstacles, such as motorway intersections, rush rivers, and airport runways. Now, this technology uses a three-stage process, whereby the first stage consisting of drilling a small diameter pilot hole along the desired center line of a proposed floor plan. The second stage, here the pilot hole is enlarged to the desired diameter to accommodate the utility line that will pass through it. Now, this utility line is then put to the drilled tunnel. As the pilot hole is being drilled, a bentonite drilling mud is pumped down the center of the drill rod. Here, the drill head consists of either a jetting head or a drill bit. Before the start of back reaming, the pipeline must be positioned on rollers in line with the hole to minimize any axial load on the line. Again, here's another video that goes into more detail the process of horizontal directional drilling.
Directional drilling makes construction projects like this one possible. Let's rewind and take a look at the directional part of the drilling. The impressive accuracy of horizontal directional drilling is achieved through careful planning, well-trained navigators, guidance software, proper setup, and advanced steering tools. A skilled driller can direct the course of the drill bit along a pre-planned path over great distances. Different formations, however, require different techniques. In alluvial or soft formations, a jetting assembly uses high-pressure fluid to remove formation while drilling. The steering tool transmits data to the navigator. The driller can now orient the bend and the hydraulic pressure toward the desired direction. The nozzle, aligned with the bent sub, focuses intense hydraulic pressure to a chosen direction. It's like holding your thumb across a garden hose to increase the spray. Pushing forward, the bit follows the path of least resistance, guided by the deflection of the bend. Once this directional adjustment is complete, the driller can go back to rotating the drill string. Harder formations require a different approach. A drill motor replaces the jetting assembly. Now the hydraulic pressure is used to drive a turbine, which rotates the bit without having to rotate the drill string. This allows the driller to orient the bend and drill in the desired direction. The string is pushed forward or slid, guided by the deflection of the bend. Once this directional adjustment is complete, the drill string can again be rotated. At regular intervals, steering data is gathered and adjustments made.
The types of trenchless renewal methods include the following: cured in place piping, slip lining, modified slip lining, inline replacement, spray in place pipe, and close fit pipe. Cured in place piping consists of inserting a flexible resin impregnated fabric tube into an existing pipe, expanding the tube, and curing using heat, which can be in the form of hot water, steam, or UV. The maximum length of this tube can be of 1,000 to 2,000 feet. And the advantages of using this trenchless renewal method is that there is excavation and grouting. The excavation and grouting is not required, and there is a minimal reduction. Not only that, but this method enables you to fill the cracks and repairing the gaps by moving through the pipe defects. Now, the disadvantages, however, of using this technology is that a flow bypass is required and a high volume of steam and water is required for us to expand the tube and cure it. Now, this can be used for structural and non-structural purposes. Slip lining consists of inserting a new, smaller diameter pipe into an existing pipe. Common pipes for usage in this are polyethylene, HDPE, or PVC pipe, and the process involves pushing or pulling new pipe from one end to another end of the existing pipe. Of course, the advantages of using this method is that flow bypass is not required, and of course we have a structural renewal. Now, however, the disadvantages of using this method is that we are limited to a small diameter of existing pipe, and excavation may be required in order for us to implement this technology. The next technology we have is modified slip lining, which consists of creating a new liner for existing pipes 48 inches in diameter or larger. The pipe sections of almost close fit is inserted to the existing pipeline, and an annular space, or the space between the new and the old pipe, is filled by grouting. This method has three variations, whereby we have a panel lining, spiral wound, and formed in place pipe. Here is a video detailing the modified slip lining and how it works and the procedures surrounding this renewal method. Pipeline replacement consists of the replacement of existing pipe using one of the following three stages, which are pipe bursting, whereby the existing pipe is broken or split and pushed outward to make space for the new pipe. Pipe insertion, also known as pipe expansion, whereby the insertion of new pipe is put into existing pipe. And finally, pipe removal, also known as pipe eating, whereby we do a complete destruction of old pipe taken out in the form of slurry. Now, some of the advantages of using this replacement technology is that we can upsize existing pipe. The disadvantages, however, is that excavation may be required and it's not suitable for all soil conditions. Here is a video of the usage of pipe bursting in the field. Now here the video will talk about the removing of a collapsed pipe that is no longer functional, and a hydraulic puller is used to pull in a new continuous welded pipe. Now the next video we have here is the usage of spray-in-place pipe, which consists of spraying a cementitious or polymer coating on the inside of an existing pipe. Now for larger pipes and culverts, SIP is incorporated with fibers or applied over steel reinforcement. Some of the advantages of this technology is that it protects against corrosion and fits non-circular or bearing cross sections. Now the disadvantages, however, are that the surface preparation is critical for the usage of this technology and it requires specialized equipment and training. The final renewal technology method we have here is closed fit pipe, whereby this technology consists of inserting a new deformed or folded pipe into an existing pipe. After placement, the pipe expands to its original size and shape to be tight inside the existing pipe. Now, the advantages of using this technology is that grouting is not required. However, the disadvantages is that flow bypass will be required and it's going to have a larger construction footprint on site. Now, not only that, but this method can be used up to 30 and 60-inch diameter pipe with a maximum renewal length being of about 2,500 feet. Here, existing pipe needs to be circular and have a consistent cross section. Now, some of the other types of trenchless renewal methods that are available on the industry right now will be underground coatings and linings, point source repair, thermoformed pipes, and sewer and manhole renewal methods. Now, underground coatings and linings, with this method, it provides higher resistance against moisture and corrosion in pipes. The materials that are used for this method includes a composition of polyester, polyurethane, vinyl ester, concrete sealers, and silicone in order to use this method. Point source repairs method is the most appropriate for local defects found in structurally active pipelines. Here, defects must be within a diameter of 4 inches to 12 inches in order to be resolved by resin sprayed using specialized machine. The next one is thermoformed pipe, which is mainly used in pipelines with very small cross sections, whereby a new pipe is folded and inserted into existing pipe, then thermoformed to develop the required dimension of the host pipe. And then finally is the sewer manhole renewal, whereby it is used to avoid surface water inflow and groundwater infiltration. With this method, it results in avoiding structural damage and materials against corrosion. And the physical characteristic of the structure, age, type, and condition of the site on the manhole system must be analyzed before choosing this method. Now, some of the emerging trenchless technologies that are coming up on the industry would include the usage of new chemical compositions in chemical grading, which can provide extra characteristics of water tightness, which increase structural durability of sewer manholes, variations of ILR using pipe ramming, and also use synthetic cementations composite mats, as we can see on the picture on the right, which is basically similar to invert paving and which uses flexible cement impregnated cloth with a PVC backing. Trenchless construction methods are cost-effective, environmentally friendly, and can reduce traffic congestion on the construction site. They generally have low labor requirements and require little site restoration. Not only that, but this type of technology also reduces environmental construction hazards and also reduces the impact on noise and air quality on the surrounding site. Trenchless renewal methods themselves are commonly considered permanent rather than a temporary repair. They can mitigate corrosion, leaks, infiltration, loose or open joints, cracks, breaks, and splits. And some of the common reasons for using trenchless renewal methods are to fill or cover over a structure, go ahead and limit surface disturbance. Uh, People use it because of the economic and cost benefit of using this technology, and they are much faster than doing open cut on the site. And of course, here's a look at our references. Thank you very much. This is the end of our presentation, and I hope you have a good day. Thank you very much.